Hi, I'm Mark Gingras. My last video, I showed you how to interface with the Twitter API using R and scrape in tweets based on your search results. I advise you to step back and watch that video. If you haven't, you might be a little bit lost during this video. We're going to talk about cleaning the data and using some analysis techniques and creating a word cloud. Again, go back to the previous video if you haven't created your Twitter API account that's free to get these access tokens and these API secret keys. Don't forget that these keys are not public, so keep those to yourself. That's why mine are all X'd out. Okay, so for all you users out there that are still following along, I've added a couple libraries, the TM, text manipulation, the word cloud, and the PLYR and rcolor brewer. Let's go down, run those libraries, run your API keys, and set up your Twitter authorization. I've already done those steps. Now we're going to collect, I'm going to put down the first 3,000 tweets. I'm going to collect those in the tweets_trump. It's a search Twitter object that's being returned. I don't really know a lot about that object, so what I want to do after I've collected these tweets is convert them to a data frame, something that we are way more familiar with. Now this might take a few minutes, maybe a minute or two to actually happen, so I'm going to continue talking while it's gathering those tweets. So on line 21 is where we are next. It's going to convert, based on this function here, my search Twitter object into a data frame. And once that happens, I'm going to explain to you, I'm going to show you the data frame. Oh, it's already up, so let's do it. So I'm going to convert it to data frame now so I can show it to you. And that shouldn't take nearly as long as scraping those tweets. And my next line, 22, what I am actually doing is I'm telling it, the data frame, to get rid of all the columns except for the first one, because I'm only interested in that first one. So all rows, comma, first column is what I'm going to set it to. Why? Let's take a look. So I clicked on tweets.txt, and you see all these different columns here. Most of these columns are not really useful to me. They might be useful to you, so you might want to keep them or do something with them. But I'm interested in just this text one right here, the very first column. So I'm going to go ahead and just go ahead and delete the rest. And that's what line 22 does. So let's run that. And you can go back to tweets.txt. Oh, now it's a vector because it's only a single column, so you can't click on it in the view mode. So we're down to one column, that text column. Now we have to create a corpus. A corpus is a collection of articles. You can have a collection of articles about Trump, a collection of articles about Clinton, a collection of articles about skateboarding. Doesn't matter. That's what a corpus is, a collection of articles. Usually probably a large collection. Multiple collections of articles, multiple numbers of corpus is a corpi, just so you know. So let's create that corpus object on line 25. I will run that, and it's not looking directly for where the corpus is or what text encompasses that corpus. It's actually looking for the source of that corpus. So you have different parameters you can put in the source right here. So it says vector source. My source is that tweets.txt data frame. Now the vector source can change. That's why it's a dynamic source. So therefore, that's what the corpus function is asking for, the actual source, not the actual text itself. So anyways, we created the tweet.corpus. Now there's a couple of helper functions that I've created and Googled a lot of to try to get these to work. There's quite a few things to Google out there that'll help you with this if you can't figure it out. These two sites will get you in the right path. But I wanted to remove URLs. I wanted to remove anywhere where it said @ and then the username. I wanted to get rid of that. Get rid of emojis, and get rid of special characters before I do anything with the text. It just makes things easier. Now these are all functions, so I'm going to go ahead and load these into memory by running them. I didn't actually do anything yet except for load these into memory. So those functions can be called anytime, and that's what I'm about to do here. So this very first call I'm going to do is on line 35. Tweet.corpus equals text manipulation map, and then you bring it in the tweet corpus. And you are using what they call a content transformer function. I believe that's just a way to validate that the function is going to work for this TM map. It's nothing special. Just plug in your function here where tweet.removeURL is, and it'll go ahead and run that function on all of your articles basically. Our articles are individual tweets. So let's go ahead and click enter on that. And then I want to inspect the first 4 and let's see what it looks like. So here we are down here in my console area. My number 1 is, it says @superdupe blah 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 blah, all this stuff. Typically I don't want to keep things like after the @ but sometimes you will lose relevant information, like @ and then somebody's name that's famous, that might count. But if it's @ somebody's name that you don't know, somebody's friend of a friend, that's why for me I just get rid of them all, and I hope the best for that. So the next one is remove the user, the @ and the user. Let's inspect again and see. Now you see I don't have any @ symbols with a username in here. So that's gone. The very next line on line 39, remove emojis, because those will cause you some headaches if you don't. Remove special characters, same deal. Strip the white space. If I have 2 spaces or 3 spaces or an enter, I don't want it, so let's remove that. Because we're going to do an analysis on this text, and you know, is it fair to do an analysis on 1 word space versus a 1 word no space, or hello I'm versus hello space space I'm, things like that. So remove the white space. Let's get rid of that type of problem. And then we're going to remove the punctuation, and we're going to make it all lowercase. And the next one here is called a stop word, and you get to plug in your language of choice. There's a list of them, but language is English, and what stop words are the simple words like and, a, the. Those don't really mean anything for statistical analysis. I mean, those words are everywhere, so I want to get rid of them. Let's not count them at all. But I also added a couple other words in here, like capital RT, because retweet is always in there, and RT is always in there, and I know that ahead of time. So I don't want those to be in my corpus. Real Donald Trump I put in there, but the @ function, the remove the @ should have taken care of that anyways, but just in case I threw it in there as well. So let's go ahead and hit enter on that one and remove numbers. Okay, so I'm going to go ahead and inspect again. I'm going to go back up to 38 and run that just to show you like what this now looks like. And I know there's spaces in there. You can run the space one again maybe. In fact, let's see if it actually works. Let's go to line 41, hit enter, and then let's go back to inspect and see if it... Okay, so spaces were added because I removed a bunch of words afterwards. So maybe we'll add that line. Let's see, line strip white space. Well, let's just go ahead and do that at the very end. So let's cancel that one out and plug it in way down here. And now we can only have to use it once. So here's what it looks like. Super dope, keeps promises. Will still, you know, a lot of it doesn't make sense, but we're looking at frequency of words, how long they show up, how often they show up. Okay, so we stripped the white space. Going down, we are going to now use this thing called the term document matrix. And we're going to bring in our corpus, the one that we just cleaned up. This one here, that's 3,000 rows long. We're gonna use term document matrix, and what that's going to do is it's going to take all 3,000 articles. It's going to check for all the frequency of all the words and see which word is in which article. And it's pretty handy. In fact, I'll show you what it looks like in just a second here. So let's run that, and then we're going to run the next one because we can't really see the term document matrix in our viewer for RStudio, but we can see an actual matrix in the viewer. So let's run line 55, and so our ap.m should be in the viewer. And now, like I said, it's 3,000 articles and all the words that are in there. So it's going to be a pretty large matrix. Okay, so you see the words going down the left-hand side. I am not sure why 1 and 2 are missing. But anyways, they're going down the left-hand side. And you have, down here it tells you 4,092 different words that showed up in 3,000 articles, and the articles are displayed going across the columns. Now RStudio has a limitation of displaying 100 columns. There actually are 3,000 columns though, and I'm going to show you that in a second. So these number ones here say, hey, the word promise shows up in article, usually these are lined up, I'm not sure why they're not, but I'm guessing that's article 3 of 4. So the word promises should be in article 3 of 4. Let's close this out and take a look at it. Because we did the inspect, or we can do it again. We can type in the console, inspect, and then let's put our corpus in there, which was tweet.corpus, and let's put in line 3 and just see what it looks like. I don't see the word promise in there. The fact that it was not lined up scares me a little bit, but let's just see if it's somewhere in there. So I typed in 2 and it shows key promises. Something's not aligned up, but that's not going to bother us for what we're doing. Okay, so we've created the term document matrix. We've created the matrix itself that we can view and use and manipulate. Let's show the dimensions of that matrix, because I showed you it was only 100 columns in the RStudio viewer. But if you do the dimensions, which is line 56, it shows 4,092 by 3,000. Okay, then we're going to sort these by a sum of those rows so that we can kind of get which words show up the most. And that's what line 57 does. Line 58 is going to create a data frame. And let's take a look at that data frame. ap.d. That data frame is taking the highest frequency words and is showing us basically the frequency count per word. Okay, so the next part, I create this PAL2. I didn't actually create it. I got it from the exact example from this website here, and there's a bunch of other examples too. So when you do that, it's going to create like a color palette. That way it'll reflect multiple colors when you use this word cloud. Read up on it from line 60 website. Now this PNG is going to create a PNG file, which is like a photo or an image file. Everyone should be familiar with that. It's like a JPEG, but usually no background. So I'm going to run that one, and you can change those dimensions to whatever you want, if you want it smaller or bigger. And then I'm going to run the word cloud, and then I'm going to say dev off, and dev off is basically just saying, hey, this PNG file, all right, everything that you've displayed, that's all I want. I'm done grabbing it. Okay, so learning this word cloud function here, you have different parameters you can use. Go ahead and research more on word cloud. Play with what I have here and see if you can manipulate it the way you want. But these parameters are you can easily look those up. So if you go to real Donald Trump PNG file that it just created in your working directory, if you don't know your working directory, you just type in get wd. It should be in your working directory, and mine is called real Donald Trump. Let's take a look at it and see if it worked out good. There we go. So there's my word cloud. Just created that. There's minor errors that we had. We could clean up a little bit, and I'm curious to see what kind of word clouds you come up with. So feel free to post links or post on the blog or comment on the YouTube videos. Hope this video helped. Sorry it was pretty fast and a little chaotic, but good luck on your word cloud.